Hey, hello everyone. So today we are going to solve this LeetCode problem 226, which is invert binary tree. It's an easy problem considering you know the recursion. It's way more easier in that case. But we are considering this problem also trying to explain how the recursion here works. So the input is basically this tree, which is 4271369. We have to just give the mirror image of this tree, which is basically inverting the binary tree, so the root node will remain root, and at each level we will just switch the leaves of the root node. So here the root will be 7 and the leaves node is basically 6 9, so we will switch as 9 6. So at each level the switching is happening. So 4 will remain 4, 2 7 will switch 7 2, and for 7 it will switch 9 6, and for 2 it will switch 3 1. So this is the inverted form of this given binary tree. So let's jump to the solution. So considering this input that I have taken as 4271369. So how is the recursive call basically working? We are going from the root node to the left, from this left to this left, from this left to this left, which is null. Then it will return, come back to this the caller node. Then again it will check right of this, it is null, it is returned back to this. So while um, calling, we see that the base case, in order to terminate the recursion, we have that base case of null value, that if the root is equal to null, we will just return null. And since we are calling the invert tree recursively, so we are calling left of the tree. So this is basically being called as invert tree root dot left. All right, and we are calling this left left left, and then after that we have to go root dot right. Now we have the left value. Since we are going to left left left, it is returning null. So we have the left value in the which is null, and the in the edge, I mean in the case when it has been iterated to the end of the uh, left node traversal. So we get the null value and we will store that null as a tree node left is equal to null. Okay, the same will happen for right. Okay, and it will look like something tree node right will be root dot right. So left left, and this left of this is null, it will come back to 9 9. Then right of this, which is null, it will come back to 9. So how it is coming back to 9? So it is coming back through this root equal to null. So when it is this null is returned to left, then this part of the recursive call is executed. So it will considering the root node of 9, it will come to the right of the 9, and then it will again call and see null is returned. So it will get null being returned here and right, and then basically what we are going to do is see that how this left and right part of this 9 execution is done. Now we want to return this to the caller, which was the previous caller, which was 7. So in order to return that to 7, um, we have to return here the root. So what was the root here? 9. And what is the left? Null. What is the right? Null. We are returning what? Root to the caller. What was the caller? 7. So 7 called 9, and 9 called null, null it got returned, and 9 is being returned with this null null iteration to 7. Now 7 was called from here recursively. Now 7 has executed the left part. Now 7 wants the right part. Now the 7, now in case of the 7th level, the left value is 9, and now it will call the right part of 7, which is 6. So it will call this right part of this, which is 6, and then it will check it is not null. It will come here, it will check left of it, right of it, the same logic, and now eventually this right variable will have the 6, which is the right node of the 7, and the root node is 7. So now this 9 and 6 will be swapped after this. So now after executing the null condition, now we are at the leaf node of 7. 7 as a root node, 9 and 6. Now we have left, which is 9, and 6, which is right. Now we need to swipe this. So swipe at which level? We want to swipe that root dot left as right, and root dot right as left. So this is how it should work, and this was a simple logic of how recursion works here. So the problem was easy because it is easy, but the tricky part is how recursion basically works, how we can visualize the recursive call and how we can think of that this left and right recursive call basically goes, and how this return statement has an important role in returning to the last called execution. So this is how nested recursion basically works, and this is how tree problems are basically called recursively. So this was a simple problem. See you in the next question. Thank you.